Hello. Today we will deal with dependent t-test using SPSS statistic. Prior to previous class, we had independent t-test. This dependent t-test using SPSS statistic is to deal the data before and after. Okay. We might think that there is many cases like that, before treatment and after treatment in case of the medical care, and also in the athlete field after the training by the coach, and then before the coach, right? Like that one. The comparing two variables before and after. We use this kind of statistic. It's called the dependent t-test. Okay. Now, we will forward this method. Okay. Comparing to our prior independent t-test. Okay. We will see that introductions. The introduction is just now. I told you that this analysis method is to detect whether there is any progress or not. Okay, so comparing two variables. But we have assumption here. What? This assumption is very important. These two groups is separate by before and after, but this is the same group. Okay, on the basis of the same group, we compare before and after. Okay, not different group. That's the reason why I call this statistic analysis as a dependent t-test. Okay, I have to recall your memory regarding independent t-test. The independent t-test is the separate different two groups, right? You remember that. Independent. The meaning of independent is the two group is not related separately. Okay? The sample should be separate. But in this group, dependent t-test is a sample is the same. But not sample. The group is the same. But the variables, the parameter is before and after. Okay? Before the shot, after shot. Okay? And the before the treatment, before the training, right? Like that. Okay? So the most typical measurement of this type of analysis is to measure the progress and advance of the student studies, like comparing, two variables. For example, the students, just one student, not one student, I'm sorry, the one group of students, like a certain, unit of or a certain grade, and then we measure the score of the subject, for example, regarding the mathematical, test score before and after they has taught by very competent, teacher, and then test after, then we compare these two before and after, and then we will see that whether there is any difference of mean. I told you the mean in statistic is the average, meaning that comparing two average before and after of the score of a certain subject, like that. Okay, so we will compare anyway before and after of the same group, okay, which is typically used to check the progress and advanced of a student. Okay, before testing, after testing, like that. Okay, anyway, there is the introductions of the when this statistic analysis is used. Now, we will go to the assumption here. Okay, well, we have to check the assumption prior to running the main program. Okay, main analysis. What is the assumption of this dependent t-test? We should meet the assumptions to run the program because the assumption is a basic requirement of the program asking, right? So if you do not meet, actually if your data do not meet this requirement, you cannot proceed, you cannot implement the program or analysis. Why? Because you did not meet at least the minimum qualifications of the data. So, meaning that your data is not buried. Your data is long to use. Okay? That's the reasons why we have to check the assumptions of each analysis. These assumptions, let's see what is the assumption of this one. Assumption number 1. Your dependent variable should be measured on continuous scale. We have already run the continuous scale, okay? For example, okay, the continuous scale is composed of two species. One is the interval and one is the ratio level, okay? The interval level and ratio level, this is similar, but one thing different is the ratio level exists actual 0. Okay, but interval level do not exist any concept of 0, right? That's the difference between two levels, two variables. Anyway, number 1 assumptions to run dependent t-test is that the variable should be interval or ratio level, okay? Anyway, regarding the type, uh, I can give you some example of the interval and ratio, right? What is belong to of each of variables, and then we say the IQ, the intelligence, right? The IQ score measured actually is it is a 0. Okay, if suppose that so certain people's the IQ score is 0, but the 0 is not actual 0. We just determine, we just use the level 0, but actually there is no persons who has 0 intellectual, right? So in this meaning, 0 is not an actual 0. It's just for the measurement, okay, of the degree of their intelligence. So in this meaning, the 0 is not actual 0, but the 0 is considered in case as an actual 0. In this case, we can distinguish this one as like a weight, your weight, okay, like that. Your weight measured in kilogram, okay, like that. Okay, the meaning of this one is that the interval or ratio level to distinguish these two levels is whether the 0 concept is actual or not. Understand? The 0 concept, okay? Anyway, whether it's an interval, okay, whether it's an interval or ratio, the assumption number 1 for analysis in the dependent variable it should be the dependent variable. The dependent variable is your object variable, right? This is your object variable. It should be what? 0, okay? I'm sorry. It should be interval or ratio, okay? Meaning that it's categorical numerical variables, okay? Not nominal variables. The meaning of the categorical and numerical is the variable should be notified as a number, not as a known, not as a name, okay? The independent variable or target variable should be number, measuring interval or ratio. Remember that. Number two assumption is, what about the independent variable? The independent variable should be what? Okay, the independent variable is the group. Okay, whether it's one group or two groups, anyway, it should be group. Okay, but in this case of the dependent t-test, the group should be what? Should be what? Should be one, right? So one group but different variable. One group, the same group but different variable. The different variables meaning that before and after variable. Okay, then we have checked assumption number 2. Okay, then let's go to assumption number 3. Assumption number 3 is that no significant outliers. Okay, there should be no significant outliers indifferent between the two related groups. What is the outliers? The outliers is something outstanding. Okay, if there is something outstanding variable, that variable makes some twist of the whole variables. So in this case, the outlier should be omitted, should be deleted, right? I have experienced these reasons enough in my class, okay, right? Because if you find an outliers and the variables, you have to get rid of these all things, because these outliers can twist your result. Okay, so if you have any outstanding figure which is quite higher or quite low from your average number, that number should be deleted. That is outliers. So your significant outliers, if there is existing, then it should be deleted. Okay, then that was our assumption number 3. And now for assumptions, what is that? The distribution. The distributions should be normal distributors. Okay, it's normal distributors. What the meaning of normal distributors? The populations of your statistic data should be normal distributor. Okay, okay. The meaning of normal distributors, you have to enough. Okay, normal distributors. If it is not normal distributors, your data result will be also twisted. Okay, then we have the 5. Okay, have 6 assumptions. Then dependent t-test, we have just 4 assumptions to meet as a minimum. Why? Because this test is done just for the same group, not different group. So we do not read, we do not need any homogeneity. The meaning of homogeneity is similar deviations. The similar deviations of 2 groups, right? So in this case, we use the Levin test, but we don't use Levin test here. Why? Because we are just examining targeted one group before and after, the same group. So we don't have to compare the groups. Okay, Levin test is used for labeling whether there is the similar deviation between 2 groups. It should be to meet the requirement. But in this case, we are just to analyze for one group. So we don't need any Levin test because there is no another group to compare. Okay, this test is only comparing before and after means difference, whether there is any average difference before and after. Okay, so we have checked all assumptions, and you have to keep in mind that Once you answer your questions and exam, you should present these assumptions, at least 4 assumptions, then you can get higher score. Okay? Because I emphasize this is minimum requirement. This should be tested done prior to you run your main test. Okay? So this is very important procedures of you to check prior to your main statistic. Okay? Okay, then we will test in SPSS, okay, with the example. Okay, then you have data, right? You have data, meaning that you have 2 variables. You have 2 variables. Then in this case, you have data jump 1 and jump 2. Okay, with the name. By the name of this variable, you can easily detect this data is might be to compare prior and after. Okay, the before and post. Okay, because why? You can easily detect by number 1 and 2 with the same variable name. Jump 1, jump 2. Okay, it's easy to tend to check whether before and after. Okay, anyway, we have data here, and then now as it is seen, so you have 17 data of each variables before and after, but to meet the minimum requirement of normal distributions, it should be at least 30. Okay, 30 of the variable data is more stable, and if you get more than 30 variables, the data, automatically you complete normal distribution. So you don't have to add any unnecessary things. So please correct data at least 30. Okay? And then we have 2 data, and we open this one, okay, by coding. I have taught you how to code this data into, well, into Excel, right? We have practiced this one in our lab, and then we have to importing this Excel to where? To SPSS, and also how to import this file into SPSS. We have already practiced many times. So I believe you can do that even automatically, how to import this one. Okay? Okay, after importing, you open SPSS program. Okay, I think so you know how to open this one in our lab. Then okay, then we see that this is the screen of the SPSS, and you go to the analyze, okay, menu bar, and then you will pull down the menu bar. If you click this one, so you can detect there is the descriptive statistics, the compare mean, and general linear model, okay, generalized linear model, the mixed model, the correlate regressions. So many options here, right? Many options, but we select compare means, right? Because why? T-statistic is the method to comparing the means and detect where there is difference between means. So we select compare means, and again we have another pull down menus here, and then mean, one sample t-test, independent sample t-test, and failed sample t-test, one way ANOVA. So this is a failed sample t-test. Okay, so the meaning of failed sample t-test is the test of the same group but different data before and after. So we select this one. Okay, and then we go to the next screen. Then there is one more popping up screen here. Then okay, failed sample test, the title on the top, and you can see the variable jump 1 and jump 2 on the left. right? And you have the arrow here, and if you select jump 1 and just double click, or once you select this one and if you push this arrow, then this jump 1 will be moved to the right, okay? The field variable, okay? So we have to send these two variables together to the right, okay? So you select the jump 1, double click, or jump 1 selected and then push arrow here. And jump 2, and we have to send to the both of these variables from left to right, okay? Then you can see here on the right, the field variables, okay? Variable 1 is before, variable 2 is after, right? You have to select this. You have to fit the variable corresponding variable 1, variable 2. The variable 1 is the data before, and variable 2 is the data after, okay? Then there will be, okay, like this, okay? If you push according to my instructions, you can see that this kind of a screen, okay? Jump 1, jump 2 is moved from left to right, like this, okay? And then, okay, next, what we have to shoot here, okay? So, options menu. You have to select the option menu. Okay, option menu is over here on the far right position, the upper position of this screen. And then, okay, you see the, okay, here. What is the core confidence interval percentage? Okay, this percentage 95% is your confidence level. The meaning of confidence level is that the possibility of your hypothesis is right. Okay, you select 95%, meaning that your hypothesis, you are confident that your hypothesis, what is the meaning of your hypothesis? Your hypothesis always, I told you in a previous, the video clip also, your hypothesis is the possibility that you will right. So you set 95% possibility of your hypothesis will be right. Okay, then 95% here. This is the usual, the setting value of social science. But in case of medical science, you have to increase the possibility up to 99. Okay? Okay, like that. We select this one. Okay. Then we will see the output. The important thing is you have to have your ability to translate the output of the dependent t-test. This is important, right? Because you have to report this one. In our exam too, right? In our exam, you should have clearly explain the result. In other words, the meaning of translations of result. Okay? So let's see the result here. This is result. Okay? For the sample statistics, the result. For the jump 1 and jump 2, the mean is 2.4 and 2.5, which is similar, right? The number of the observation is 20, 20. This is the number of what? The data. The data 20, the data 20. Jump 1, data 20. Jump 2, data 20. The data, the number of data before and after, if this is the same, you will have a higher punctuality of this statistic, right? So if possible, please pair together this number together, okay? And then standard deviation is almost similar, okay? 0.16, 5, right? So almost same, right? And standard mean error is almost 1.3 and 1.3. Okay. Okay. So this is the what? This is the just okay here. Okay, this is the table, and then this is the result, the fair sample test result. Okay, the failed jump 1, people jump 2, and mean again. Standard deviation, standard error is most similar, and then okay, we have to check this one. Okay, this is the significant level, and then this is the possibility, p-value, right? P-value is almost 0, meaning that we have to check this one. We have to check this one, okay? The meaning that, what is the meaning of this? Okay, this is the t-statistic. If the t-statistic is the minus 4.7, the p-value level is almost 0, meaning that you have almost 0% of possibility to be wrong. Okay, then, oh, I'm sorry, this is not shown in the, okay, here, right? The meaning of significant here, right, is that this is almost 0. The meaning of this one, you have to emphasize this one. If this is, in other words, this is p-value, I told you, right? This is p-value is almost 0, meaning that this result say that the possibility that your hypothesis to be wrong is almost 0, meaning that your hypothesis will be accepted. Okay, so you have to have your ability to translate the result of this table, that your possibility is almost your possibility. What possibility? Your possibility. Your hypothesis to be wrong is almost 0, meaning that you are right. Okay, what was your hypothesis? Okay, there is difference before and after, so meaning that there was some advanced. Okay, there was some advanced, something done. Okay, between before and after. Okay, so you have to use this table. Okay, you have to, okay, I have introduced you how to copy this one. If you copy this one, just if you have a click on the right, and you can find the copy of this one, and you can copy this table and paste it on the reporting. Okay, by using the MS Word, and you make the reporting sheet, and then you file it and send to me by email. Okay, as soon as prior to finished this exam class, then that will be accepted as your answer. Okay. Okay, thank you.